At the atomic level, physical contact between everyday objects never truly happens. Your brain creates the sensation of touch by interpreting powerful electromagnetic repulsion between the vast electron clouds that surround every atom's nucleus, maintaining separation across nanoscale gaps even when surfaces seem pressed together. Atoms consist of a minuscule central nucleus holding protons and neutrons, enveloped by enormous electron clouds that fill over 99.999% of the atom's total volume, with electrons behaving as probabilistic waves spread across fuzzy orbitals rather than solid particles whizzing in neat orbits. When your fingertip approaches a table, trillions of these clouds from carbon, oxygen, and hydrogen atoms in your skin begin interacting with silicon, oxygen, and metal atoms in the wood or glass surface, starting at distances of several nanometers. Electrons, all carrying negative charge, immediately sense their counterparts through electrostatic forces, repelling with intensity that grows exponentially closer, surging from gentle nudges to unbreakable barriers as separation drops. This charge repulsion follows basic rules of like charges pushing apart, strongest when clouds compress into the same space where probability densities peak. Quantum mechanics adds an ironclad layer through rules preventing identical particles from sharing exact states, generating steep resistance whenever electron waves from different atoms try to occupy overlapping regions, like an invisible wall born from wave function antisymmetry. At slightly larger separations, fleeting attractions arise from momentary charge shifts in one atom inducing opposite polarities in neighbors, drawing clouds together temporarily before repulsion takes over at intimate ranges around 3 to 5 angstroms. These competing pulls and pushes establish stable distances in solids and molecules, where atoms vibrate in place without ever merging or colliding. In everyday solids, thermal vibrations keep clouds dancing around these equilibrium points, while applied pressure from your muscles, forces generated by ATP-fueled protein motors contracting fibers, transmits through skin layers to frontline atoms which halt against the table's atomic barrier, deforming molecular bonds slightly but never breaching the gap. Friction grips through surface roughness, creating tiny repulsion hotspots, amplified by partial attractions in moist air, allowing you to lift objects as collective forces sum across billions of interactions into macroscopic strength measurable in kilograms. Skin's mechanoreceptors convert this deformation into sensation. Fast-adapting cells fire at skin slips or vibrations up to hundreds of times per second, slow-adapting ones sustain signals for steady pressure, all transduced through ion channels stretching under strain to spark electrical impulses racing along nerve fibers at speeds topping 100 meters per second toward the brain's parietal lobe. There, somatosensory maps integrate timing, intensity, and location into rich textures. Smooth glass versus rough sandpaper emerges from burst patterns, hardness from sustained force levels. Evolution crafted this system over billions of years, starting from simple organisms sensing pressure gradients for feeding, advancing to primates wielding tools where precise tactile feedback meant survival through object manipulation and threat avoidance. Brains now predict solidity using layered priors, cross-referencing vision and proprioception, fooled easily by illusions where stroked rubber hands match visual strokes, remapping body schema to claim fakes as real. Materials showcase repulsion's range. Diamond's tetrahedral carbon framework interlocks clouds for supreme resistance to deformation. Metals let delocalized electrons flow within rigid lattices for conductivity. Plastics tangle polymer chains enforcing bulk through steric hindrance. Liquids flow as heat overcomes local attraction wells, sliding clouds past each other while repulsion prevents true fusion. Gases scatter widely, ignoring interactions altogether. Rare breaches occur in quantum realms, like microscope tips sensing atomic contours through wave leakage across vacuums mere atoms wide, or ultra-cold atom clouds blending into shared waves under extreme chill, but daily life suppresses these. Probabilities plummet as barriers thicken beyond femtomotors. Surfaces under nanoscale probes appear as isolated hills separated by valleys, contours warped by cloud squeezes rather than bumps touching. Perception layers deepen the illusion. Attention gates signals through thalamic filters. Emotion amplifies or dulls via descending pathways. Placebos blunt hardness through expectation alone. Cultural honing sharpens experts. Watchmakers discern micron flaws tactilely through neural plasticity, reallocating cortex real estate. Synaesthetes paint textures in colors. Blind readers pass braille dots at millimeter precision via heightened somatosensory acuity. Philosophers long pondered empty space dominating atoms, now confirmed by scattering experiments pegging interatomic voids vast on microscopic scales, solidity emerging purely from force gradients steep enough to mimic walls. Heat introduces vibrations rippling through lattices as phonons, loosening grips for diffusion without penetration. Extremes like stellar cores crush electrons into protons under gravity's override, sustained only by particle exclusion. Every handshake, footfall, embrace unfolds this atomic drama. Electron clouds clash invisibly across eternal buffers, repulsion gradients forging unyielding pushback, nerves weaving electromagnetic murmurs into seamless connection. Your brain, master storyteller, narrates solidity from quantum whispers, scripting reality's most convincing deception across voids too small for sight, yet mighty enough to shape worlds.